Hello and welcome to the tutorial of Introduction to Transducers. Before we see the definition of transducers, let's see the block diagram of generic measurement system. It consists of three components. The first being the input device, then we have the signal conditioning device and the output device. Consider an example of the dish connection which you have at home. You have the dish as the input device which gets the electromagnetic signals from the satellite. Then it is converted into some kind of signal which would be understood by the set-top box. Here the set-top box becomes the signal conditioning unit, and then in turn it is given to a TV which becomes your output device. Here the input quantity is the satellite signal which is received by the dish, and it's a non-electrical signal. It then needs to be converted into an electrical signal. Keeping this in mind, let's see the definition of transducers. The transducers are the devices when actuated transforms energy from one form to another. In the above example, the electromagnetic waves coming from the satellite is converted into a form which would be understood by the set-top box. Another definition of transducer is a device which transforms a non-electrical physical quantity into an electrical signal. Let's look at the classification of transducers. The transducers can be classified on different parameters such as physical phenomenon, electrical, that is the kind of electrical outputs which it can produce. Depending upon the output, that is if the output is analog, it becomes an analog transducer. If the output is digital, then it becomes the digital transducer. Then the power which is supplied to the transducers. Let's look into this in detail. The physical phenomenon consists of some transducers which will first convert the mechanical form and then into an electrical form.
Hi everyone.
So the mechanical part becomes the primary transducer, whereas the electrical part becomes the secondary transducer. Let us understand this with an example of a mic. In this mic, usually you will have a diaphragm which would be placed inside the mic. So the sound waves which come will be converted by this diaphragm. So it will be converted into displacement, and hence it will be called as the primary transducer, and the displacement of the diaphragm, that is the movement of the diaphragm, would be converted into electrical signal which would be called as the secondary transducer. The next type of transducer which we will be seeing is the electrical one. As already mentioned, it depends upon the output, that is the electrical quantities in which it converts the form. That means either the signal would be converted into a resistive form or a capacitive, inductive, or some kind of light form. The next type of classification for transducer is the power, that is active and passive transducers. In active transducers, we have the transducers who do not require any external power, that is you will not be connecting any power source, and hence they are also called as self-generating type. Some of the examples are the thermocouples, photovoltaic cells and photoelectric cells. Whereas the passive transducers are those who require power mostly from an external source. Some of the examples of this kind of transducer are under resistive. There are thermistors and strain gauges. Under capacitives, the different gauges. Let's look at the selection criteria for transducers. When we need to decide or choose which transducer to use, there are some basic selection criteria which we should know. The first criteria is the input characteristics, like type of input, the operating range, and the loading effect. The type of input, we mean that the input quantity to be measured, whether it is temperature or distance or the quantity or amount of light. Once we know the input quantity, the range, how much it will vary, is very important for the choice of the transducer, which is determined by the operating range. The maximum limit decides the transducer's capability while the lower determines the error. The last is the loading effect. That is, the use of transducer should not affect on the input quantity being measured. The next is the transfer characteristics, which consist of transfer function, the different errors, and the transducer's response to environmental condition. Let's start with the transfer function. The transfer function of a transducer is a relationship between input and output quantities. Let Q0 be the output quantity and Qi be the input quantity. So transfer function is defined as Q0 as a function of the input quantity. Let's look error in detail. Error is defined as the deviation from the relation of input and output quantity. Epsilon here is defined as the error, whereas Q0 is the desired output and Q0 dash is the obtained output. Let's look how the errors are divided into different types. The scale error, dynamic error, errors due to noise and drift, and errors due to the frequency response of the transducer. Let's start with the scale error. Under that we have zero error, sensitivity error, and the non-conformity error with hysteresis error. Let's look at zero error. Zero error is the error with a constant factor, given with this example of graph. The blue being the desired quantity and the red being the output, which is actually we are getting in the practicals. So the distance or the difference between both of them is constant throughout and is linear. Whereas in the sensitivity error, what happens is the variation is non-linear, but still a constant value difference is maintained. In non-conformity error, variation for every input is there. Hence, it is called as non-linearity or non-linear distortion. Under hysteresis error, all transducers show effect of hysteresis. In this, the transducers behave differently for the input and for the output. That is, if the input is increased or input is decreased. So, the transducer will behave in a different way. The dynamic errors are possible when the input quantity is varying with time. Errors due to noise and drift and frequency response needs to be handled very carefully while choosing the transducers. The last selection criteria is the output characteristics. Under this we have type of electrical output, output impedance, and the useful range. The type of electrical output, such as voltage, current, time functions of amplitudes, should be such that it matches the next system. Usually we would need to manipulate either amplify the signal or convert it into digital for proper use. The output impedance of the transducer would determine the next stages of instrumentation. Output impedance should be as low as possible to minimize the loading effect. It cannot be zero, but it should be maintained as less as possible. The output range or the useful range which we will be using from the output should be also appropriate with consideration of the input range. To conclude, what we have seen today is the basic definition of transducer, the classification of transducer, and the different selection criteria to choose a transducer. Hereafter, in the following lectures, we would be seeing the detailed construction, working of electrical type of transducers. For today, thank you.